Alright, dear children, now we move to the next topic from this chapter on nuclear structure. And the topic that we do now is atomic masses. And with respect to atomic masses, we measure these atomic masses by the smallest unit, okay, and that is called unified atomic mass unit. As we commonly call this as atomic mass unit, AMU. Okay. Now, basically atomic masses. So atomic masses refer to the masses of neutral atoms. So atomic mass basically refer to the what? Masses of what atom? Neutral atom. Neutral atoms. The neutral atom means the atom which are not in ionized form. Now that means the total number of electrons present around the nucleus or move around the nucleus is always equal to the number of protons present inside the nucleus. So that the net charge in an atom is always 0. And such atom is called neutral atom. Now this atom, the masses of neutral atom includes the masses of nuclei. Includes the what? The mass of what? Nucleus, or we can call as nuclei, because for more than one atom, okay. Then followed by the masses of what? The masses of orbital electrons. Because in an atom, the nucleus is present and the electron revolve around the what? Nucleus. Which means the mass, atomic mass, okay, means the masses of the orbital electrons, whatever number of orbital electron, okay, their mass plus the mass of the nucleus. Okay, that measures the atomic mass of the nucleus. And the mass equivalent to their energy is called binding energy, and that part you learn in the next chapter, okay. But we actually now focus on the atomic masses, and the most important part is to measure this atomic mass by the smallest unit called atomic mass unit. Now this, since you know that atom is a smallest particle, okay, of the element, okay, being too small, the masses of atom, even the masses of nuclei, even the particle present inside the atom like electron, proton, neutrons are always expressed and measured in terms of the unit called unified atomic mass unit. What unit? Unified atomic mass unit. So unified atomic mass unit is expressed by letter U, small letter U. So this is the smallest unit that is used to measure the mass. But especially this unit is used to measure the atomic masses. Even the mass of the nuclei, the mass of proton, electron, neutron, and even other particles also. Okay. But one atomic mass unit, also called one unified atomic mass unit, is always measured corresponding to the mass of carbon atom. And you know carbon is one of the elements which can be found abundantly in nature. Okay, but carbon has how many isotopes? 3 isotopes. But out of 3 isotopes, we take one of the stable isotope of carbon, and that stable isotope carbon is C612. 6 is the atomic number, 12 is the what number? Mass number. And children, when we measure this unified atomic mass unit, which is expressed small letter U, also simply called atomic mass unit. Now children, you have learned this as AMU, but we also call this as unified atomic mass unit, symbolized 1U. And this one unified atomic mass unit is defined as 112, means 112 means 1 by 12, the mass of one C612 atom. And C612 atom is carbon atom, which means we write down 1U, one unified atomic mass unit, is always 1 by 12 into the mass of what? The mass of one carbon C612 atom. Because as I said already, carbon is one of the most abundant occurring in nature, one of the most abundantly found element in the nature, having isotopes, and this is one of the isotopes of carbon, and one of the stable isotope of carbon is C612. Okay. Now, by the definition, the mass of C612 atom is exactly how much? The mass of C612 atom is exactly 12.00000, okay, U. And U means what? Atomic mass unit. Now, to express one unified atomic mass unit, okay, that is actually equals to what? 1 by 12, the mass of one C612 atom, carbon atom. So with this unit, we can measure the mass of any atom other than the carbon. or even we can measure the mass of any of the subatomic particle. Okay, but in order to measure this mass, okay, so we write this mass, atomic mass unit, in terms of kg, because kg is the SI unit of mass. But this unified atomic mass unit can be expressed even in terms of what? Kg. Now children, you know that that we have learned in chemistry also, 1 gram atom of any of the element has n number of atoms, and n, capital letter N, which the symbol which I am using is called what number? Avogadro's number. Avogadro's number. And you know what is the value of Avogadro's number? Basically 6.02, okay, 3 into 10 power 23. Okay, so even for carbon C612 atom, 1 gram atom, suppose you have 1 gram atom of C612 carbon, and that means this 1 gram atom of C612 carbon even has how many atoms? N atoms. Okay, N atoms. This is according to Avogadro's hypothesis. Okay, and this N atom of carbon C612 means that carbon has how many gram? How much gram of carbon is there? 12 gram of carbon is there. 12 gram of carbon. Okay, so the number of atoms present in 1 gram atom is N atoms, and this N atoms of C612 contain how much gram of carbon? 12 gram of carbon. And this 12 is actually also equals to what number? Molecular. This is also called molecular weight in gram. Okay, molecular weight in what? Gram also. Okay, now I write down therefore the mass. Therefore the mass of N atom. See, the mass of N atom of C612. See, mass of N atom of carbon mass is equals to how much? 12 gram. As for the hypothesis, Avogadro hypothesis, so mass of N atom, capital N atom of carbon C612 is 12 gram. Then the mass of one atom, only one atom of carbon will be 12 by what? N gram. So I simply divide this by N. Okay, simply divide by what? N. But the value of N is called Avogadro's number. So experimentally, so we take the value, correct value, okay, and the value experimentally is 6.0221 into 10 to the power 23. So this is actually the exact value of Avogadro's number. So exact value of Avogadro's number is 6.0221 into 10 to the power 23. Okay. So if I take this value and substitute, okay, then we can calculate the atomic mass unit in terms of what? Kg. So this is the value which we calculated, that is mass of one atom of carbon C612, that is 12 by N gram of carbon. Okay. Now as for the statement, one atomic mass unit is 1 by 12 into mass of one C612 atom. Now this mass of one C612 atom is this much, 12 by N gram. Now let me substitute, then we calculate the one atomic mass unit in terms of kg. So one atomic mass unit equals to 1 by 12, okay, into mass of one carbon atom I have substituted as 12 by N gram. So this 12 and 12 what? Cancel out. If 12 and 12 cancel out, it will be 1 by N gram. So one atomic mass unit is also equals to 1 by N gram of carbon C612 atom. Now let me substitute the value of N. So after substituting the value of N, so U1 atomic mass unit is equals to 1 by 6.0221 in 23, and the unit is what? Gram. This G is what? Gram. Now in order to simplify this, okay, okay, we can write and calculate the value of U in such a way so that what I do, I multiply numerator by 10 and also multiply denominator by 10. So 6.0221 into 10 to the power 23 into 10. So children, look at it. What I have done, I multiply and divide by 10 in the numerator and denominator. Okay. So this is actually why, because now I can divide 10 by 6.0221. So if I divide 10 by 6.0221, you get approximately 1.6605. So children, you can do the division with your calculator. You get this value approximately 1.6605. Okay. Now, okay, into now 10 to the power 3, 23 plus 10, 1 means 10 to the power 24. And when I take in the numerator, it is 10 to the power minus 24 gram. See, power of denominator is 10 to the power 23 and 1. 23 plus 1 is 24. Then 10 to the power 24 from denominator, if I take in a numerator, is 10 to the power minus 24, which means 1 atomic mass unit is equals to 1.6605 into minus 24 gram. But I convert this into kg. And you know 1 gram equals to how much kg? 10 to the minus 3 kg. Because 1 gram means actually 1 by 1000 kg. So 1 by 1000 means 10 to the minus 3 kg. So I convert now from gram to kg. So finally 1 U equals to 1.6605 into 10 to the power minus 24 into 10 to the power minus 3, and now it will be kg. Now look at the power. The bases are same. The power will be added. So it will be now minus 24 minus 3 means minus 27 kg. So now look at the value. So 1 atomic mass unit is also equivalent to 1.6605 into minus 27 kg. Now this is the relation that we use to convert from atomic mass unit to kg. But atomic mass unit is the smallest unit that is used to measure the mass of atom, nuclei, proton, neutron, electron, and even other particles also. Okay, so this is the relation between atomic mass unit and kg. Now in the next YouTube video, okay, we do with the energy. We do the energy equivalent to this atomic mass unit. Okay, and this energy equivalent to atomic mass unit is actually need to be calculated on the basis of a very famous equation expressed by Einstein, that is called E equals to mc square, and that we do in the next YouTube video.